Young Engineers Building Structures and Towers by Tammy Enns. Table of Contents. What is a structure? Footings and foundations. Beams and joists. Columns. X-braces and shear walls. Glossary. Find out more. Index. Some words are shown in bold like this. You can find out what they mean by looking in the glossary. What is a structure? Structures are all around us. Most people live in a structure. You pass lots of them when you go out. Structures and towers can be almost any size or shape, but they are built from many of the same parts. These important parts may be hidden underground, beneath floors, or inside walls, but they are keys to holding up buildings and keeping you safe. What kinds of structures do you see every day? Footings and foundations. The first step in building a structure is making a foundation. Without foundations, heavy buildings would sink into the soft soil beneath them. Sometimes structures sit on buried concrete columns called piers. Piers carry a building's weight to sturdy rock layers beneath the soil. Other structures sit on footings. These large slabs of concrete spread out a building's weight. Piers are designed to support a structure's full weight. Experiment with footings. See how footings work in this experiment. You will need a pillow or cushion, 2 to 3 cans of the same size, a piece of thick cardboard, 5 inches or 13 centimeters square. Number 1, place the pillow on the floor. Set a can on its center. Number 2, stack another can on top. What happens? Number 3, remove the cans and lay the cardboard on the pillow. Number 4, stack the cans on the cardboard. What happens now? Do the cans sink in as far? Are they more stable? Beams and joists. Beams and joists are the structural parts of the floors and roof. They're often hidden beneath the floors or above the ceilings. Beams need to be strong enough to support people and things stored in buildings. Beams come in different shapes and sizes. They can be made from wood, steel, or concrete. Joists are the horizontal pieces that support a floor or ceiling. Joists are made from small pieces of steel or wood connected together. Joists, beams and joists form a strong skeleton of a structure. Experiment with beams. Beams are placed on their edges, not on their flat surfaces. This allows them to carry more weight. See how it works with this experiment. You will need 2 empty cereal boxes, tape, 2 stacks of books, 2 to 3 cans of equal size. Number 1, place the open ends of the boxes together. Overlap their tabs. Number 2, tape the boxes tightly together to make a beam. Number 3, place the beam on its edge, spanning the book stacks. Number 4, place the cans on the middle of the beam. How many cans can it hold? Number 5, now place the beam on its face, spanning the books. Number 6, how many cans can it hold now? When loaded up, beams experience tension and compression forces. Tension forces stretch parts of beams. Compression forces squash other parts. Beams that are too compressed buckle. Beams that have too much tension tend to snap. Steel and wood beams stay strong when stretched and squashed, but concrete beams need to be reinforced to stay strong. Compression, tension. Engineers must carefully balance forces in their building designs. Modeling a reinforced concrete beam. Concrete beams break easily, but with a little help from steel reinforcing bars, they remain strong. Make your own reinforced beam. You will need pieces of polystyrene foam about 2 inches by 5 inches by 1 inch thick, and 2 wooden skewers. Number 1, hold the ends of the foam and slowly bend it until its bottom begins to crack. Number 2, carefully slide the skewers into the foam about 1/4 inch from the bottom of the beam. Place them about 1 inch apart. Now, bend the beam again. Do the skewers keep the beam strong? Columns. Beams support all the weight of the things inside a building, but columns support that weight and the weight of the building itself and carry all of it to the foundation. Beams at each building level connect to columns. Columns can be any shape, but often have square or circle cross sections. Longer columns are less stable than shorter columns, and they buckle more easily when loaded up. Columns help engineers create buildings with many floors. Experiment with columns. Test out the strength of long and short columns with this experiment. You will need 3 sheets of paper, scissors, tape, books. Number 1, cut 2 pieces of paper in half lengthwise. Number 2, roll and tape each piece to make 4 1-inch round columns. Number 3, place a column under each corner of a book. Carefully stack on more books, one at a time. How many books can the long columns hold? Number 4, cut another paper into fourths. Roll and tape each of these pieces to make 4 short columns. Number 5, load up the short columns with books. Can they hold more? X braces and shear walls. Beams and columns support lots of weight, but there's more to making a building or a tower stand straight and tall. A lateral or sideways system prevents wind from toppling structures. X braces and shear walls collect wind forces and carry them to the foundation. You may not see these braces, but even tall glass buildings have hidden lateral systems. X braces are used in many different types of structures. Experiment with shear walls. Shear walls are walls inside buildings that carry wind loads to the foundation. See how they work with this experiment. You will need empty cereal box, tape. Number 1, open both ends of the box. Number 2, place the box on its edge and tape it to a table. Number 3, push against one side of the box. How easily does the box tilt? Number 4, now tape the open ends of the box closed to create shear walls. Number 5, push against the side as before. What happens now? Do the shear walls prevent tilting? Build a braced tower. X bracing is another way to keep buildings straight and tall when the wind blows on them. See how it works with this experiment. You will need spaghetti noodles and gumdrops. Number 1, break 2 noodles in half. Use gumdrops to connect the pieces to the square. Number 2, repeat step 1 to make another square. Number 3, break a 1-inch piece off 4 more noodles. Number 4, use these long noodles as columns to connect the squares into a tower. Number 5, push sideways on the top of the tower. What happens? Number 6, add noodle X's across each side of the tower. Now what happens when you push it sideways? Structures and towers are amazing to look at, but there's more to them than meets the eye. You know about their important parts. They all need foundations. They all need beams and columns to carry the people and the things inside them. Just as important are braces and walls to keep them tall and straight when the wind blows. Engineers work hard each day to design the next great building. Glossary. Beam, a support for floors and roofs. Buckle, to bend under force. Column, an upright support pillar. Compression, a force that squishes. Cross section, the shape you see when you cut through something. Footing, wide concrete slab under a building column. Foundation, support at the bottom of the building. Joist, beam made from short pieces of steel or wood supporting part of the structure of a building, horizontal piece that supports a floor or ceiling. Lateral, sideways. Pier, an underground support column. Reinforcing, making stronger. Shear wall, a wall designed to resist wind forces. Structure, the load carrying parts of a building. Tension, a pulling force. X brace, crossing members that resist wind forces. Find out more. Index.